So, since I don't speak very well in Serbian, so I'll speak in English, so I hope everybody understands. Yeah, a bit different topic, but still related to the energy savings. It's about how good control enables you savings. Yeah, so before we talk about good control, what does that mean? Sorry, I still need to get used to the pointer. Yeah, but basically good control means when you have control of your system, let's say under control, you have linear response of the system. Now, how do you get that? In case of fan coil or air handling unit, with a characteristic of heat transfer like this, it means you need to have with the valve an actuator with a counter characteristic like this. So this is really important to understand additional behavior later on. So now we know we need a, let's say, logarithmic valve actuator characteristic. Okay, we get, this is what we get also from all data sheets and prospect. But what does that mean? I mean, because we have two options, either pressure dependent or pressure independent solutions. So what's the difference? The difference is the classic or pressure dependent solution has been measured in laboratory conditions, which means under constant differential pressure control. Now, what does that mean? When you put a classic valve inside the system, it means immediately when you close and regulate the flow, the pressure with the constant, let's say constant pressure drop over the system, the pressure over the valve won't be constant anymore. Why is this important? Because as the pressure increases, it will affect your original characteristic and it will deform it to something like that. And why is that important? This characteristic will have an effect to your system. And you will no longer have a linear system, and that means you will no longer have one control parameters for your system. That means a lot of work with the system as well. So that's with one valve. If you put many valves in the system, it means they will have interaction between each other, and they will have effect to each other. And that means you have all kinds of conditions inside the system, which are not predictable. And that means also your characteristic and response of the system won't be predictable. And in the end, if you use, what's the difference with a pressure independent valve? Actually, the pressure independent valve has a differential pressure controller built in, which maintains constant pressure drop over the control valve, therefore maintaining all the time laboratory or factory conditions. Yeah, so all these oscillations and impact from the fluctuation of pressure have two effects. The first one, what we can see here, is so-called overflow. It means when the system will go in partial load, which does a lot, it means the pressure will increase and therefore the flow will increase. And it will take some time to system to adapt properly. The second one is when you go, because you get a change of characteristic, it means also get a change of response of the system. It means in the lower demands, lower loads, you might have also oscillations. So now we talked about two different solutions or impact of different solutions which you install in the system. So now let's talk about the system itself, the pump. We know all this started with the advanced technology of the pump, with the frequently driven pumps. So the question is, can you use advanced technology of the pump with both solutions? So, and what happens here is, when the system is running at the design conditions, and everything is calculated to the design conditions, everything is running perfectly. Now, when you go to partial load, it means you have an overflow, overpressure. And then if you use the advanced control of the pump, it means let's say you use proportional control with a pump head with a, let's say, control ratio of 0.5. It means at the end you will have 50% of pump head. But what does that mean? The last unit will still have enough available pressure. But all the rest will have less pressure, because this unit here was designed for this amount of pressure, but now in the partial load it only gets this amount here. So you will have so-called flow starvation. So the answer is, if you use advanced pump control, you might you will risk causing some units to starve. So it's kind of recommendation not to use it. And also there's some guidance how to minimize the risk. But whatever the risk, there's always a risk. This is actually solved with the pressure-independent solution because all the units require the same amount of pressure that the last one. And this is in all conditions is guaranteed. So only by using the latest technology also in the valves and the actuators enables you also to use the latest technology of the pump. And why is this important? Because the pump, even though consumption is not that big part of the system, it has an impact to all the other components. Now in case, because this is mainly the forum for district energy or district cooling, it means it will also have a big impact on delta T. We'll talk that later a bit. So, talking about the savings, where we can actually save the savings. We know that the consumption in the HVAC system is mainly built from three components: pumps, chiller, and fans. And where we can actually, by having good control, where we can actually enable savings. So first of all, which is quite obvious, is the pump itself. The second, by providing the right amount of flow and running the system at the most efficient one, we will also provide the best delta T, which means we will also enable the best performance of the chiller. And by the end, of course, with the good control, without oscillations, with the minimum deviation of temperatures, it means it also enables us for overall savings. So it means we can increase the set point in case of cooling, we can increase the set points in the room, or in case of heating, we can decrease the set point in the room, and we will still be in our comfort zone. So what I did for this case, I did a simple calculation. I took one system with 1 megawatt cooling capacity. I'm talking about the cooling system now. I've taken the cooling, let's say the running hours of half a year, and with the electricity cost of 0.15 euros per kilowatt hour. In this case, the pump head is required around 27 meters for 2.7 bars. And what I did compare here, in this case, was two different solutions. So classic versus pressure independent, and with three different pump controls. One with a constant dP, and then with a proportional dP. So, when we talk about the performance of the pump and the flow profile, so when we talk about different solutions, so we talk about on-off and moderating. Because there's still a lot of units that are using on-off, and it's still the awareness of how important this on-off, or what are the benefits of this moderating versus on-off. Just to give you a better idea. So with the on-off, it means runs 100 or 100% or 0. So in case of, if you want 50% cooling capacity, if we simplify it, it means 50% of the time will run at 100% and 50% it will be on off. Or it will be 50% on 50% flow. So that means if you do this for every point, basically you get linear, let's say linear relations between the flow and the load. This is for the PACV. With the classic, like I said, because it's pressure dependent, it means you will have overflows. And that means your actual characteristic or your actual flow will actually even be higher at certain cooling demand. Now, like I said, if you want to have linear response of the system for the fan coil or heat exchanger, ideally this would be the curve. And this can only be achieved with a pressure independent solution. With the classic one, this curve, when installed in the system, will get something like that. Yeah. And about the pump head, so there are, like I said, there are three controls options. So first of all, on-off for the PSV or classic is the same. If you want to have constant dP, both of them will require the same pump and the same performance of the pump. The difference is when you want to use the modulation in the classic one. We know the performance of the classic can be improved by improvement of authority. And that means usually it requires bigger pump head. So all the classics, even though later on you won't have the performance as you wish, usually they run at higher pump head. Okay. But talking about the PSV or pressure dependent, it means we can have those three options. Either constant dP, proportional calculated, or this is usually already installed in the pump itself, or you can use remote DP sensor. So the idea is also here to show, is it worth putting some additional money and time investing in running pump at this station. And you can see here below from DANFOSS, these are the efficiency where each performance run. And you can see how much bigger area you can cover and how lower you can go with the efficiency and the power consumption if you lose the last one. Okay, before I go to the results, every system has a certain load profile. It means, in this case, what we have taken for this calculation means our system runs on 50% cooling capacity around 19% of the time, and 24 on 30% and so on. And for that, if you remember the characteristic, it means, for example, at 50% load, we only require around 20% of the flow. Or, if you look forward on, it means 80% of the time, our system will be running at really low flow. Why I'm pointing out this is because it's really important, because this is where classical and all other solution actually suffers a lot. What happens, like I said, with the change of characteristic, your system response gets really steep or really fast. It means your PID settings in the loop will be too slow or too fast for this system, which means you will have oscillation. Also, what we have seen previously shown on our control demo panel, which you can also see in our stand, it means you will only be able to control with a classical in certain area. Below here, you will have more or less on-off control. Okay, so now to the results. So what we can see, for the base, I have taken the calculation with the on-off constant with a constant dP. And this is my reference number. So basically here we got like 50,000 kilowatt hours. And this is my 100%. By just going down, you can see actually you can reduce the pump cost by 80%. So you can run the same cooling capacity for only 20% of power for the pumps. Because you can have the same amount with a delta T of 2 degrees or with a delta T of 10 degrees. The ratio of the flow will be also 5 times slower the flows, therefore. Okay. And that's also important. This is also where also for the district energy or district cooling providers has a big impact. Actually, if this is the characteristic of fan coil, at 100% or the design conditions, let's say it's 712, so 5 degrees delta T. Now, if you're over pumping, it means the flow goes too fast through, and has no time to give all the cooling capacity out. It means it returns cool back. And this is so-called, or also known as the low delta T syndrome. And what's more important is, I'm not sure how it's in Serbia, but you can answer this one. In some countries, also especially Middle East, if the users, or let's say a house or a commercial building, is not meeting the demand, the design demand, they're being penalized for it. And they're paying penalty for returning too low delta T. So, for district energy, because also the district energy providers are suffering because their efficiency of efficiency of the system is suffering as well. You know, again, on the other hand, by running properly in the lower load, it means we are increasing delta T, and therefore we are increasing also the efficiency. Now, if taken this chart from one of the chiller producers, this is the efficiency with the different delta T's. If this is constant delta T, this would be efficiency with the load for different delta T's. Now, with the on-off solution, basically your system would be running on one of those curves. With the PICV, if design delta T is 5, it means it will have also all the time 5 delta T. With the classical, it will drop down a bit. But what happens if you use proper modulating? Actually, your delta T increases, and therefore you don't lose on the efficiency that much. If you put this characteristic inside the calculation, you can see you can get up to 18, in this case we calculated 18% of savings on the chiller efficiency. And then the last one, like I said, good control means less oscillations, means better control of the temperature, means also enables you to set or increase or decrease the set temperature in the room. And we know by increasing, in the case of cooling, increasing the room temperature for 1 degree, it will actually give you 10 to 15% of energy savings. Because the demand for the cooling capacity is that much lower. So I have taken for this calculation assumption that the chiller consumption is around 60% of total energy, and I've taken this, that also proven by field tests and case studies that easily you improve or enable to improve the indoor temperature by 1 degree. So it enables you, the PSV with the modulated control enables you to increase up to 15% easily. So overall, if I sum it up, so in this case, for the 1 megawatt system, we would use like we would have like 6,000 euros savings on a yearly basis, or 78%. 16,000 on the chiller, or 18% overall. These figures are so, in case you have other systems, you can easily calculate what kind of impact we are talking about. And also, like I said, additional one enables you around 15%. So, summing up all of those three together, we are talking about 44,000 euros per year by just having good control. Without any, let's say, any less quality or even improved quality, but the same demand. For better, for easier understanding calculation, if you would have those, if our system would have 500 units, that means 90 euros per unit. Just to think it, how fast do you get from switching from classic on-off or PSC on-off, then you can go to the modulating. Because this is often being challenged, the payback time or the money spent in. Yeah, so the conclusion in this case, it's not only the savings, it's also the PSV gives you perfect control in all conditions. Means also you won't have any problems, no overflows, no low delta T. Of course, savings, and also you can use the advanced technology of the pumps. Overall, we believe you can save with 20 to 50% on the heating on the HVAC system by using PSV with the modulation solution. That would be from my side. Any questions?